Okay, so our first part here, 11.3, arcs and central angles, use the properties of arcs of circles. And we got our first answer to be 14 because it's 2 times the radius. And then our second question is, what type of angle is formed when a circle's radius connects with the tangent line? So what type of angle is formed? This is from yesterday's notes. It's a right angle. So that's this one, a right angle. And then our next one is about drawing secant and tangent lines. I'm going to put my circle up here so you can see it a little better. I know that that's a really thick line, but that's only to help you guys see it better. So when you draw a secant line, how many times does it intersect the circle? Secant. So we have a tangent line, and that has a point of tangency, which tells us it only hits at 1. So tangent line hits once. I asked about secant, but you guys gave me the answer for tangent. So I'm telling you the tangent one first. Tangent. I'm going to put that here. You see it hits just one time. And then over here, that means the secant has to hit how many times? Twice. So anywhere in here you draw, as long as it hits twice, this is going to be your secant line. Secant. Okay, so that is our bell ring. Are you guys okay if we move on? Is the measure of the minor arc. So remember, we associate minor and major. Minor is smaller than major. So our minor arc is the measure of its central angle. It's going to be less than 180 degrees, and we name it with the 2 points. Our major arc, it's going to be the difference between the minor arc and the total interior of the circle, which is at 360, and we name it with 3 points. And then we have a semicircle. You guys have probably seen semicircles before. It's half of a circle, and that's going to have that measure of 180 degrees, and again, we name that with 3 points. When you're here, you see that AB is your minor arc. It is the one less than 180. AB, and you see that your central angle is the one with the vertex at the center of our circle, and so that one would be ADB. You have your major arc, which is going to be starting here, ACB, and you label it with the one in the middle of that. So you could do ACB or BCA, and you put a little arc motion above it. Yes, ma'am?
Are we supposed to be writing that little top thing?
Nope, I have all of this already on your page, so you should be fine. It just was a misprint. So that's all I wanted you to see on here. And then we're going over to this one. So this is just labeling major and minor arcs and then how much their measure is. So I'm going to hit my annotate mode. And then get a color you can read in. Okay, so I'm going to go right here. Our minor arc. What is the name of our minor arc? It's RT, so we name it RT. You put a little arc above it. And then we want to know the measure of our minor arc. When we do our measure for our minor arc, is we just put a little m, and then we put the RT next to it. So what is the measure of our minor arc? Okay, which part? I rewrote the arc and then just put an m in front of it to let me know what's the measure. So I'm telling you how much it is. What's the degrees? So remember how we write like measure of an angle? Measure, angle, sign, angle.
So you basically just wrote the same thing, just gonna be
It's the same thing. Like this label told me what it is. Which one's your minor arc? You told me the name. This one's telling me how many degrees. What's that measure of it? By putting the little in. It's gonna be 50 degrees. Okay, our next one is our major arc. What's our major arc?
So
RMT or TMR. Put a little arc above that as well. The M has to be in the middle. Yes, sir. You take your 360.
you subtract it from 42.
You subtract 50 from it. And that gives us 310. So the measure of M equals 310. Okay, we're going to move on to our next one.
Any questions on our homework page?
I'm not sure it's right there, hon. Okay, our minor arc here. Minor arc, what is it?
42.
It's 42. It's hard to see. So it's 42 degrees. Oh yeah, it's ADB. Thank you. I'm sorry. I'm all out of it. So it's AB. And then your measure of AB is what he just told me, which is at 42 degrees. We have our next one is, I'm sorry, what's it going to be? It's going to be 318. And how do we name that? So we got 318. He did 360 minus 42. So gives him 318. And then what is the name of our major arc? ADB. Yep, EF. And you guys just told me it is the measure of EF, 63 degrees. We have a major. What's our major arc? EHF. Gotta make sure that H stays in the middle. And then the measure of
297.
You guys told me it's what?
297.
Thank you. Sorry. 297. We have congruent circles. Two circles are congruent circles if they have the same radius. If two arcs are the same or of congruent circles, so they're coming from those congruent circles, then the arcs are congruent if they have the same measure. So if they have the same measure and they're in the same circle, their arcs are congruent. If they have the same measure and they come from two circles that are also congruent, so they have the same radius, then the arcs are going to be congruent. We want to talk about our arc measurements. So arc AB, what's its measurement?
It's 80 and it's equal to
80. And we see that DC, gentlemen, equals 80. So we know that the measure of AB equals the measure of DC. Now I want to ask, are these arcs congruent? So that was what our last slide was about. Are these two congruent?
Yes.
They're the same size? Do they have the same radius or in the same circle?
Yes.
Yes, they're in the same circle. So yes, we can say that they're congruent. So we can now say that arc AB is congruent to arc DC. Over here, we want to talk about these two. We have arc AB again. What is the measure of arc AB?
AB.
Yep, Xavier? Okay. So what's that measure of AB? It's going to be 50. So we have 50 degrees. And then we have arc DC or CD. What's its measure? It's going to be 50. So are these two angles equal? They are, right? The measure of angle B and measure of arc AB is equal to the measure of arc DC. Are they congruent? The measures are the same?
Yes.
Are they in the same circle? So technically it's a circle in the circle, but they're not in the exact same circle. And are their radiuses the same? They're not, right? Because this circle's radius is from here to here. And this circle's radius is all the way out to its edge. So no, these are not congruent. AB is not congruent to CD. You want me to draw that out a little better? You guys want to see that? Where the radius of your smaller circle, let's go back to a color we actually can use, is just right here. That's your smaller circle's radius. Your larger circle's radius is this whole side. They're not the same length. So, you have to recall when we're finding arc length that it's going to be a proportion of the circumference of the circle because the arc length itself is part of the circle's circumference. The formula for circumference is 2 pi r. We're going to need that. You need to make sure you remember that. The way we find this is multiplying the circumference of the circle by your central angle and then dividing it by 360. So I wrote this out in a little bit more of an equation form. So let's see if I can get it in a color that you guys can see. If If I go with orange, look at the top corner. Can you read that?
No.
Okay, if I did it in white, can you read that?
Where is white?
Yeah.
Oh, yeah.
Okay, so here we have arc length equals, I did the measure of AB as a generic way of writing an arc all over 360. I would just like you to write this below underneath the part where you just wrote the 2 pi r. So underneath that little space or out to the side. You're going to have this test on Monday.
That's your quiz.
It's a quiz.
You want me to go to sleep?
I don't. So we're going to find our arc length down here. Javion, Rio, arc length. Your arc length is what value? You're going to have your measure of your arc, which is 100. You divide it by 360. And then you multiply it by the circumference, which is 2 pi r. My r is 5 centimeters. You know that 2 times 5 is 10. And then you know that 10 goes into 360 36 times. And we can continue to reduce, or you can just put in your calculator.
Yeah, let's do
So if you put in your calculator, you would have 100 pi divided by 300 or 36. And that gives you what value? Did you get it, Mike? Oh, I thought you were like raising your hand.
Teacher tried to
Hold on.
Where did 10 come from?
How do you go from 1,000 and then under it equals 32?
If you said it's 105,
It's 100 and pi. Pi. So we have pi there. Is there another number after that? It's 8.73.
Oh,
And it's a length, so you're going to keep those centimeters.
seems like
So our first step for arc length is going to be your angle. What is your angle here?
4 feet.
So that's your radius.
Oh, 90.
It's 90 degrees over 360 times our circumference, 2 pi. My r is 4 feet. We know that 90 goes into 360 4 times. 4 goes into 4. So I now am left with 2 pi. What is the value of 2 pi? 2 times pi. Okay, our last one real quick. Arc length equals 60 over 360 times 2 pi 8 feet. This deserves feet on it as well. What value do you get when you do that? Well, 60 goes into 360 6 times. 2 goes into this 3 times. You end up with 8 pi over 3. Not yet, guys. What do we get for our final answer? Just tell me real quick so we can be done. You have a calculator, so I provided to you. 8.37 feet. On your way out, make sure you